Good morning, everybody, and welcome. And I hope you've had really good sessions last night and everybody's getting to know each other and sharing good ideas. And, I must say it's been an incredibly good conference. And we now have a really important talk this morning. We've Dr. Paolo Bertoldi, who is a senior expert in sustainable energy, climate, and he's in energy, climate change and energy efficiency, all three at the European Commission. Some of the key areas of expertise of Dr. Bertoldi include energy service companies, market-based instruments, governance, environmental leadership, ICT energy consumption. And the title of Paolo's talk is Improving Energy, Carbon and Water Efficiency in Data Centers for AI. So a really important topic. Thank you, Paolo.
So much. Thank you for the nice introduction. Thank you for inviting me to the very interesting conference. I hope you are fresh after the nice reception last night. I understand someone went on to the pub. I skip it to be fresh today to give a reasonable good presentation. As you heard from my introduction, I'm not an ICT expert. I'm not coming from this. I'm coming from the energy world. Been all my life working in energy since I started after my degree, and energy and climate change. So that is a strong link, as you know, and I'm going to tell you in a few slides. So how to move on the slides. Okay, so no surprise, I just give you a couple of introductory slides to frame a bit my presentation. So global greenhouse gas emissions and global CO2 emissions, CO2 are caused by combustion of fossil fuels, are still increasing despite the Paris Agreement in 2015. So we have not yet peaked. Some experts say we may peak in this year, so it means become flat, and then finally they start slightly to decrease, but we are not yet there. So more emission in the atmosphere. What does it mean? It means that our global temperature will become hotter. We are already reaching, in fact, what was the target of the Paris Agreement, try to limit the temperature increase compared to pre-industrialized period. To 1.5, we are right now at 1.4, 1.5. Prediction, we're going easily to 1.6, and then depends what we do. We'll see where we're going in terms of global temperature. You know all what this means. No surprise. It means more energy in the atmosphere, causing an increased number and more severe climate-induced natural disasters. Just showing some, but you are all aware of forest fire hit in Greece, California, Portugal, drought in some country, causing maybe migration because people don't find water, and water is needed for growing food, for living. Hurricane, flooding. Flooding is very common. It's hitting everywhere. US, Pakistan, Europe, and this flood is more frequent and more severe. So the message is the temperature is going to increase. This will be increased. So I'm not talking about, but I'm talking mainly about mitigation, not talking about adaptation, but adaptation will be as important as mitigation. And by the way, another natural hazard that it's very hard Europe and causing a lot of deaths, and not many people talks about, are heat waves. Our city become very hot in their period, especially in Southern Europe, but also Central Europe more and more, where temperatures stay above 30 degrees for several days, and there's no air conditioning, and maybe people, elderly people, people with diseases may find difficult to survive. Sorry, I'm going the wrong direction. So what we have to do is to decline our emissions. And by the way, this is the ideal green scenario of the Paris Agreement that most probably is far too late to implement. So we are looking now to stabilize the temperature at 2 degrees or going up to 2 degrees eventually in future after 2015, going back down to 1.5, but very much depends not anymore on mitigation, but on removing carbon or greenhouse gas from the atmosphere. But if we don't do much, we stay in the blue band, and this means 3 degrees. So it's really doubling the temperature increase from the 1.5 to 3. So very dramatic scenarios, and there's no agreement who will do most of it. Developing country, you know, the largest emitter is now China, or the US. India is growing, but India say we have the per capita very low greenhouse gas emissions. So it's you, European and North American, that have caused this. So you should reduce much more than we do. So there is still a lot of discussion in the frame of global climate talks and climate justice. But in any case, the scenario is quite dramatic. So if we move now to Europe, we are a small emitter now, 7% of global emission coming from Europe, in particular the EU, living outside the UK. But we are still a moral engagement because we emitted a lot. We are a relatively rich nation with access to technology, so we should reduce our emissions. And in fact, we have good targets for 2030, and we aim to be a climate neutral society or economy by 2050. And we have this intermediate target 2030, where we want to reduce 55% of greenhouse gas compared to 1990, increase the renewable share in total energy consumption of at least 42%. We are about 22, 23 now. Some countries are much more advanced. Again, the Nordic countries, Sweden, Norway, Finland, and we are also want to reduce our energy consumption, so energy efficiency. And you see that we are in efficiency, we are doing somehow reasonably well. So we had the COVID impact in the year 2000 rebound, and then we're going down. Let's hope that trends keep going down, but still there is a gap to the target at 2030, and we are already 2025. Time goes very fast. And so there is a lot of work. And this means that every sector in the European Union should reduce energy consumption. And this is also relevant for data centers. We ask to reduce energy in buildings, in transportations, in industry, steel plants, cement plants, and also in ICT and data centers. But we know that data centers are just providing a service that is basically following the request for more connectivity, more activities related to data, so being data storing, data processing, data sharing in terms of video streaming, 5G service on the telephone, etc. So all the indicators point that the activities that drive data center consumption is growing. Internet user, internet traffic, data center workload for cloud, for storing data, processing data, even before the big expansion of AI. This data is 2022. Crypto mining is also another contribution of data center consumption. And we should not forget that whatever we consume in data center, there is an equivalent consumption for data transmission, mainly by telecom operators or fiber optic operators or satellite operators, and then in our homes with our modem or office, modem, router, Wi-Fi. So everything is increasing. And this is a slide from the IA showing basically exactly the same trends and continuing trends. My data stopped at 2022. I found recently this data at 2024. So you can see that the fixed broadband traffic is growing, but also the mobile. And with the advent very soon of 6G, we have faster connection, so even more usage in our mobile connection. So I zoom back to Europe now, showing where we are in data center consumption, because that is an interesting question. There are a number of studies which predicted consumption extrapolated to the future. So we had a very different number, ranging basically from 40 to 100 terawatt hours for data center area to 2020, and then extrapolating this to 2030. So we did a study in 2024 at the Joint Research Center European Commission, which we believe at the time was the most accurate picture of data center consumption in the EU. Unfortunately, as a caveat, we don't have statistics for data center consumption. We have a very good statistic for all the typical industrial uses or transportation mode or type of buildings. But when we look at data centers, they're not official. So do we still collect the data center of steel plants, of cement plants, of chemical plants? And maybe some countries they don't have, but for sure they have data centers. Luckily enough, 8 countries in the EU, which cover more or less 80%, have good data, either in Data Center Association or national authorities. So it was easy to compile this part of EU consumption with a good accuracy. While for the other country, we had a kind of modeling approach where no data was existing, so maybe using some proxies like broadband connections, share of the service sector, share of the ICT sector in the total consumption, and then doing some modeling. So basically, this groups the country in three bands with very good data, reasonable quality data in Austria, Italy, Luxembourg, Poland, and Spain, and poor data in other member states. Luckily enough, these member states have little data center penetration for the time being, but in future they will also expand. We not only collect the data about the consumption, but also where the data center are located. And as you know, everybody wants to be in the big financial capitals. So London, Paris, Amsterdam, Frankfurt, and Dublin. So these are the 5 locations where everybody wants to have a data center, being hyperscaler like Amazon, Google, Microsoft, or being the famous co-location company which offer space for example, the banking sector to bring their servers. There's a consolidation of data center moving from the enterprises to this large co-location data center. And then there are secondary markets like Madrid, Milan, Warsaw that are growing as well. And this causes a problem because at this location, there is not much capacity left in terms of space, physical space, but also in terms of power, because the increase has been very large in the recent years. So our study basically concluded there were about 55 to 66 terawatt hours in 2022, representing 2.7 of total electricity consumption. And about the large data center already account for 60%, while the smaller data center in enterprises, in hospital, in university are around 40%. And this will continue to shift towards the larger one. So there is encouragement, some companies don't find it any more economical to run their own data centers. They can go to a co-location, rent space, bring in the servers. And so they will make the large data center much more dominant in the provision of data center services. And of course, also the top 4 market, Germany, France, Netherlands, Ireland, are already accounting for 66% of this total consumption and will further increase. So again, another strange phenomenon. You don't go where there is power available. Nobody wants to have a data center. In Greece or Portugal, they want all to be in this financial capital of Europe. In terms of national consumption, of course, because of the size, Germany is the largest one with 18 terawatt hour of about 60, so about a quarter. But if you look at the important indicator, which is the share of data center consumption in total national electricity consumption, Ireland stands out. Already at the time I was studied 18%, I understand now is over 20%, and prediction is that Ireland goes up to 20%, to 30%. So the picture, the blue bar is the total consumption in terms of terawatt hours per country. The yellow dot is the share of total electricity. And you can see Ireland is standing out in outliers, followed by other member states like Netherlands, Denmark, and Luxembourg. with 5%, and then you can see now some member state is lower than 1%. So the EU average is about 2 to 2.5%, and it will grow. And of course, when we talk about Ireland, most of these data centers are here in Dublin area. So you can imagine the amount of energy, electricity consumption in relation to total Dublin city or county, whatever it is, consumption. Now I look a bit at the future, so it becomes more speculative. What this data presented you, we think are reasonably solid. The future, we don't know, but we know it will increase. So first of all, we are moving to the AI type of data center mainly for the development of the models and the testing of the models. And in a traditional data center, we have racks with servers, and the typical power of the racks could be 2-3 kilowatt, maximum really 10 kilowatt, but it's already, I would say the average is between or the normal racks between 2 to 5. While in a data center, the same rack will have servers from 50 to 130, so more than 10 times. And this is due to the fact that the CPU will be replaced by GPUs or other very type of chipset that allow very fast parallel computing. So from a CPU that consumes 100 to 200 watt, we're going to GPUs, it goes 800 to 1,200, maybe 3,000. I mean, this is an area where the data that I have here tomorrow are surpassed. So I know NVIDIA has already presented some GPUs up to 3 kilowatts. So we're talking about really, really impressive numbers. So the power density in data center will be much increased. The typical air cooling system that we have in our data center, where we blow cold air in the racks and then we extract it, it will not be able to cope with these very high power densities. And there is the need to move to liquid cooling. Liquid cooling is already available also for traditional data center, but is not very much used. And is mainly immersion type, but with the AI type data center, there is the need to bring the liquid refrigerant directly on the chip to really cool it down, because at this power density, there's a lot of heat generated. The good news that liquid cooling is more efficient than air cooling. It's the same development that the car industry had. Initially, car engines were cooled by air, and then the last was the Beetle by the Volkswagen. But now everyone is liquid cooling with a radiator, and so the data center will also follow the same path. And as you know, traditionally the air-based cooling is pretty inefficient. So we measure its efficiency through the PUE indicators, showing basically total energy consumption at the center. The IT power consumption divided total energy consumption divided total energy consumption, and the typical range from 2.0 for the legacy, the old type of design, to 1.2, the new design. And most probably AI data center will be all in the range of 1.2, 1.1, because we are using liquid cooling. But even if we are very efficient, the consumption is going to increase. And these are some studies that came out last year. I already told Damien that I will make the slide available, so I don't have to rush to take pictures and put it down, scribble down. And by the way, when you will read it, if you have any comment or suggestion, is always welcome. Basically, study confirming what is the current global consumption, around 500 terawatt hours, of which about 10% is located in the European Union, and then doubling this by 2030 in terms of energy consumption or capacity. So in terawatt hours, energy consumption, electricity consumption, or gigawatt hour electricity capacity. So going basically from 100 to 200. The Lawrence Berkeley Lab had a very good study based on while the other are more consultancy studies, and focus only in the US, focus only from the period from 2000 to 2028, showing basically that at the moment data center in US are already 4.4 of total electricity consumption, so double already of the EU, and it may go up to 6% to 12% according to how much AI will be built in data centers. And this is a critical point. So AI in all these estimates. So there are ranges, as you can see. This is the Lawrence Berkeley Lab study there at the middle. They show different ranges because nobody is sure. This is very deterministic. All the others show ranges because we don't know. AI is expensive. GPUs are very expensive. There is the need to have, as I say, very high power distribution, and the network is a constraint. The transformer, the power transformer are constrained. The moment is a long delivery time. So the question that investors are asking themselves is it worth to invest a lot in AI? Will be a demand for AI service by the general public, by companies that will allow the investor to recover their investment in data centers, in hardware, and in electricity infrastructure, including electricity generation. So this is why it all brings to a range, and nobody knows which way we go. The only thing that we'll know, we will increase the energy consumption, but we cannot say by exact number, but we give a range. And also the IEA gave a range, recently published in April this year, a study in particular on this side. They also give an extrapolation to 2035, and they have scenarios according to how much efficiency we implemented, but also how much growth in AI services we will have. But in any case, as you see, it's very likely that from the 500 terawatt hours that we have at the moment in the world, we will reach something between 800 and 1,000. So there is agreement that we will most probably double, and it will go to 1,000 terawatt hours. That will be 4% of total global electricity consumption. And again, that is a range because there is also demand for electrification of building, demand for electrification of vehicles. So, but still will be an important loaded data center. So it's not just an impact on energy, but also an impact on greenhouse gases emissions. And I explain to you why. So there is not enough power, and the data center dedicated to AI are demanded right now. So there is a strong increase. And so far, the industry, in particular, the hyperscaler, were good at trying to meet their data center demand with renewable energies, with a lot of PPAs, investment. But there is also the renewables are a bit constrained at the moment. We are down quite a lot, in particular in Europe, but we cannot double in a couple of days our renewable capacity. And in particular, we cannot double the capacity from now to 2030. We will maybe have 20% more, but the consumption will double. So most probably this consumption will be met with traditional power supply. In particular, gas is the most probable solutions, because we can still import gas, even if not anymore from Russia, but as liquefied natural gas, and is a conventional, traditional technologies that can be installed. So it means that part of this increase will not anymore be renewables, will be gas fire power station, and it means that will be increasing our greenhouse gas emissions. There are some pledges to use nuclear, in particular, a lot of talks about small nuclear reactors, but are not yet on the market. Maybe some will be in 2030s. And if we think about adding new traditional type of large nuclear power stations, we're looking at perspective of 10, 15 years, because the permitting, the construction time, and all the process takes a lot of time. So I don't see very much other option than going to gas. So it means more greenhouse gas emissions. The distribution this distribution system is also constrained, so it needs to be a large major investment to bring the power to where the data center are. So at both the level of transmission system and distribution systems. And so I think in future, the location will not be anymore in city like Dublin, where there is no power anymore, but most probably, in particular for AI dedicated data center, can be far away in a remote area, most probably in the Nordic country where the climate is more favorable, where there is enough power available, in particular green power, renewables, land, of course, and network capacity. Another point I would like to draw your attention is the impact of AI on fresh water consumption. Is already happening in traditional data centers. Data center use water, sometimes even fresh potable water, which in some region in Europe is scarce and will be more with the impact of climate change. So there is sometimes usage of cooling tower, which evaporate water to cool the water in cooling towers, which really waste water. And not only this, but also a lot of water is used in traditional power generation, again, for cooling, either through the atmosphere or put back in rivers. And this is not a system of solutions. And we know that even AI with liquid cooling may a bit optimize this one, but will be an impact, and there is a paper there showing that the water impact should not be neglected after the energy and the greenhouse gas impact. And not dealing then with other issues like electronic waste coming from replacing very often the servers to embedded emissions in construction materials for data centers. Beside very large data center where models will be developed and trained, and again, another number to keep in mind that at the moment, the largest data center are in the range of, I would say, 10 to 30 megawatt, sorry. Now we'll see announcement of data center campus up to 1 gigawatt. So a lot of power demand in a specific location. And as I said, this centralized, very large data center could be moved to where is available power because the testing phase does not need to have very low latency. And even we can think to have them might be to do their job when it's cooler the temperature, when there's more power available from the renewable, which are intermittent, so more flexible. And then we need a lot of smaller data center near the end users, in particular for new application. For example, think about autonomous vehicles, where the latency is very critical. So you need to basically run the models or in factory, in hospitals, this kind of application. So a lot of smaller data centers, edge data centers, which are much smaller in size, but much more dispersed, but again, altogether will consume energy. The good things that might be this can also be easily powered because we're talking a lot of smaller one distributed more ubiquitously, and also can help maybe with balancing our network with their batteries and standby power generation systems. Very quickly to conclude is to give you some ideas what we're trying to do in Europe to reduce data center energy consumption, including AI data center. So already in 2007, we started an initiative, voluntary initiative, the first one pan-European with the UK Department of Energy, I think, or DEFRA, or whatever it was at the time, and data center operators. And there's a person who was in this meeting in London, and we designed basically an initiative saying, what is trying to collect facts, data about data centers and solutions. And we came up with a voluntary European Code of Conduct on Data Center Energy Efficiency, which is still running, which has over 600 participants, where a company committed to improve their efficiency, to measure the energy consumption, which was something that before was not thought about, and also to adopt a set of best practices, so all the solutions that can make either a new design on existing data center more efficient. And this initiative has created a lot of attention and a lot of talks about efficiency, and basically now all the major operators trying to adopt our best practice. But it's not enough. So there is also regulations, it means EU law, under the Energy Efficiency Directive, EED, which has been recasted, so revised in 2023, where there's an article saying the data center operators have to collect their data and give the data to the Energy Commission. There is a European database, and this will create, of course, better statistics, knowing where the consumption is and how big it is, and will allow to do further measure. And this is also the next steps, which are already hinted in the Delegated Act, secondary legislation of 2024, saying the most probably can be a rating scheme for data center based on the data collected, and future maybe even efficiency requirement or efficiency standards for data centers. The big problem that we don't have a good efficiency indicator. At the moment, we are measuring the efficiency with the PUE, which I already mentioned to you, which does not capture the activity that is in the IT part. It's basically a ratio between the total site consumption and the IT part. So imagine you have a very bad software, or you keep running your servers because you don't virtualize, so your IT consumption goes up, and you may improve in the PUE, which is the wrong signal. So I think these initiatives are good, but we need to develop better indicators, and I think this conference could be a good venue to discuss about hardware and software efficiency indicators that can be introduced in the data center efficiency requirement. And last but not least, there's also a requirement in the taxonomy for sustainable investment. If a data center operator would like to say that these investments are aligned with the EU goals, that is sustainable and green, they have to show that they invest in efficient solution and implement them in their data centers. So very quickly, some conclusion that you may keep out of this presentation and bring home. So say, nobody dispute the fact that AI is a very important component of our future economy. It will drive innovation and bring additional services from smart cities to autonomous vehicles to healthcare, scientific research. But AI will undoubtedly require additional power and consume more energy. And the consumption will increase. And most probably, this consumption will be met in initial phase by traditional fossil fuel generation, which is not good. It is essential that cooling hardware software algorithms are efficient as possible, and we know everything how to make the cooling more efficient, particularly liquid cooling. But when we come to software and algorithms, I think this is a hot topic for people like you researchers, and very much welcome by policymakers to know how to classify the efficiency of different software provider or different algorithms running in AI data centers. Ideally, we want this additional power demand must be green, possibly renewable. But with, as I say, the other option would be nuclear. And there are talks about hydrogen as well, but hydrogen at the moment is, again, will require nuclear, is very inefficient, and we produce hydrogen with natural gas would be a disaster. We will even increase furthermore the emissions. This heat that is generated in data center must be recaptured and reused where possible. Whenever a data center is close by to a city, to a greenhouse, for agricultural service, to factories, this type of application require heat, have their own boilers that can be replaced by this waste heat. So connecting data center to district heating network for heating and avoiding emissions in other sectors, as well as the fact that data center with their storage, energy storage capacity, many batteries can also contribute to the flexibility of the network and alleviate the constraints of the network. So they can store more energy when there's more renewables in the network, maybe release some energy to the network when there is less renewables. We should also pay attention to water consumption, and we know there is a trade-off with efficiency and water consumption. And finally, going back maybe to yesterday's very interesting plenary presentation, we have seen a national policy, but most of all, local community are also very important in determining if they want or not a data center in their territory. So they should maybe impose local requirement, thermal efficiency, energy, water efficiency, use of renewables before granting a permission to build these large data centers. Of course, citizens in a village that don't want to lose power security because a data center will put at risk their supply. And often data centers should give back some benefit to the local community if you want to be there, in terms of creating more education, more sustainability project, say local renewables, giving back the heat to the local community. So this could be maybe a sustainable development for society and the data centers, and in particular, data center dedicated to AI. And with this, I would like to conclude. These are my contact information. Information about the code of conduct are in the link below. And as I said, I will make this presentation available, and I welcome your question now and or feedback over the email. Thank you very much for your attention.
Thank you very much, Paolo. And just before I throw a question, just one question myself. In terms of all of this that we're looking at is the energy supply side. In other words, data centers supply the energy, but AI is very much out of control. It's just rising. It seems to be a race at the moment globally. Is there anything we can do on the demand side? In other words, us that use our mobile phones and the users of energy and the users of AI particularly. Are there things we can do there that can help it from that side?
Oh, yes. First of all, we don't need AI at every cost. For example, if I do now a Google search in my telephone or my PC, Google proposed me an AI reply, but I didn't ask it. I was just looking for a restaurant, for a hotel, or for the energy consumption in the EU. So there is an option made for disabled Google servers to run in an AI elaboration of my query, which was very simple. So we know that, and there are studies that showing that a traditional all-style Google query consume maybe something like half a watt, maybe an AI reply that I put it in ChatGPT consume for 2 watts. So there is so we can also say, I don't need AI. We have to educate user. We have also to have the option to disable the AI.
Yeah, but can we do more by forcing it some way by a much higher cost on the amount of data you use?
Yes, exactly. But there are a lot of companies invest in AI. And they invest because they want a return on investment. They want to increase the business. So there is a lot of lobbying power behind this. And the second point is, I think, is also important that sometimes AI cannot be also giving a correct reply. So there is a lot of mistrust. No, sorry, there should be some attention when they use it.
And can the EU do something to kind of regulate that better, to make sure that they do?
Yeah, the EU is as a first economy to have legislated on AI. This is the AI Act, which puts some limits on what AI can do and cannot do it. And also there is an interesting activity, which is a center for the algorithm transparency, saying the EU is very worried about misinformation or, fake news, if you want, and the fact that how this can be generated with AI. So there is a lot of attention to this.
Yeah, so big issues, and thank you for answering that. And we had questions up here first at the back. By the way, can you hear me? Everybody okay? Yeah, hearing? Yeah.
Yes,
Thanks for the talk. It's really nice to have the European Commission point of view on AI. So thank you a lot. Good data also. So I'm looking forward for the slide. It's really nice. So given the challenges that you point out, given the disruption of the social and labor network in our societies due to AI, like, I don't know, creative works, and due to the massive exploitation of fossil mineral resources that all stem from AI, some in our community believe we should plan a moratorium on AI. That is like consider it in science, study it widely, in terms of efficiency, for instance, or use case, what is it used for? And so where are we at here with the European Commission? Is this proposal progressing, or I'd just like to at least put it on the table? A moratorium on AI, I think, solves most of the issues you proposed. Thank you.
I don't think we are anywhere in this area because AI is also a booster for the economy. So there is a lot of difficult discussion among different departments. And you don't want to constrain the economy, you want to constrain innovation. So, and it's seen as a way to increase our competitiveness and innovation. So there is a dash for AI. There are announcements. So leave aside EU, there are national announcements. For example, there was a big conference in Paris on AI, and France announced they want to be an AI hub, and they want to attract maybe 100 large data centers in France, and the same goes for other countries. So I think is seen as a way to grow, and goes, if you want, in this big debate, should we continue to grow? Is our goal only to have a higher GDP, or we have other ways to measure the wellness of our people and of our society?
Thank you. Up here at the back. Yeah.
Thank you for the presentation. My question is more on the data centers. You concluded in the conclusion, you said that to properly deploy them for AI, local benefits should be a must. But from what I know on data centers development, locally they are more known to increase the price of local for housing, creating not a lot of jobs and taking a lot of place. So what kind of benefits can be expected for the development of data centers locally?
I think it should be, this company generate huge revenues, and part of these revenues should be given back to the local communities. As I say, beside giving back heat, installing renewables might be for not making let's say there's a village, put 2 windmills in the village that the community can use so to keep their electricity price lower. But also maybe why not create a recreational center, giving money for improving education in the local community. So it's really transfer of the wealth that is generated by this activity in large and very wealthy economy to the locals. But it's just an idea. It's not stated by the European Commission. It's mainly my personal suggestion.
Right.
Thank you, Paolo, and thank you for your personal leadership on the code of conduct. It was really important to us when I was in IBM. It drove a lot of what we did on data centers. What do you think are the workforce implications? What are the skills gaps that we have that we need to train people to be able to build efficient data centers and run them well?
This is an important question because at the moment there is a shortage of skilled labor in general in ICT and data center in Europe. But data center sustainability is different because you have to couple the mechanical electrical part with the ICT part. And luckily enough, there are some a coalition of technical university in Europe which is running a EU finance project to create, and they've run master courses for data center operators. So coupling the ICT part with the mechanical cooling, power, education with a strong focus on sustainabilities. And I had the pleasure to give some lectures in this consortium of, I think there are about 8 colleges. I think it started from an Irish college, Sligo, in the West, I understand, small, but there is this course there. And it should be replicated also in maybe a major university like this one, where you form a lot of engineers and ICT expert, computer science expert, having some course on sustainability of ICT. And as I said, beside the energy, the greenhouse gases, the water, we can look also at the life cycle implication in e-waste. And I saw a very interesting post, by the way, yesterday on the fact that at some time the current server do not allow the upgrade in software and mobile telephones the same. So all this e-waste electronics implication on rare earth materials and other materials which are very precious.
Yes, we grabbed. Patricia Lago from the University of Amsterdam. I find it always ironic that presentations like yours talk about AI, correctly so, and at the same time focus on the data center industry like it is a black box and should be made efficient, environmentally efficient. And I'm very happy that you mentioned software because it's the first time that I see this mentioning explicitly. However, I wonder if it is the role of the European Commission to explicitly include the role of software, among others, AI and data management, in directives or standards, like, for instance, the Energy Efficiency Directive that you mentioned, that excludes software in the first place, and the ongoing initiative for the software resource efficiency. So to put that in the directive so that the data center industry is triggered to do something because it's not doing anything. So is the European Commission taking any initiative in this direction?
At the moment, not really explicitly, but there are some discussion. Of course, the first step that we need from this scientific community is to come up with some definitions and some way to compare software to software. Because if you want to say your software has to be efficient, you have to tell what we mean by efficiency and what is the benchmark. So if you want a POE of software, which we don't have it, so there's not much we can do at the moment. One, the scientific community, together, I guess, with the industry, as it happened for other metrics, agreed on a metric to measure the software efficiency, then can be put it in legislation or can be recommended softly and then hardly in legislation. But until then, we can recommend try to have efficient software, buy efficient software, run efficient software. But what is efficient software?
So if you are interested, the software engineering community in energy efficiency and sufficiency is very mature. So we are happy actually to contribute.
Yeah, thank you. I know there's also the open compute community is also working on this, and that will be nice. And I think in this field, we need to reach a global consensus. This is another hurdle because, you know, the industry is the same here in the US, in China, in Japan, but it's very welcome this, and maybe I can put your constituency in contact with colleagues, not anymore in the energy department, more in the digital economy department, DG Connect, that are interested in this.
So, hi, Paolo. So thank you very much again for your presentation. Not to drop alcohol on fire, but I think it's also important in this community to remember that what is happening today with LLMs is that we are moving the computational cost from training to inference. That's something that I didn't hear so much, and this is a big preoccupation, I would say, because if since 3 years ago, the most of the cost was to create those models, making them updated, today is moving completely into the inference. That means when we use. And something that I can also tell to this community that is important to put in our mind is that unfortunately we know that what is happening is that agentic AI is the next generation in software engineering. So we are starting companies and everybody talking about agentic LLM agents, which is the absolutely fortunately or unfortunately the next generation of systems. And what I'm noticing is that my expectation, my hope was that we could create smaller domain-specific LLMs for agents. But what I'm noticing from scientific papers and the industry papers is what we are doing as a community are using the big LLMs and bring them inside each single agent. This is just to say that I really hope that the data that you were showing already take into consideration what is happening. Otherwise, it will be much worse, unfortunately, not to be pessimistic, but to consider what's happening from a software engineering and development point of view. On second comment, I'm done. I see here talking a lot about how much AI consumes, but I'm not seeing the other side, how AI can help to make data centers more sustainable, how AI algorithms can optimize the way we distribute computation. Because I'm always, hearing this negative side of AI that there is, but I didn't hear so much so far about how we can use AI as an instrument to improve efficiency, sustainability of data centers. So I would like if you have any comment on this part. Thank you.
Yes, there is basically already the utilization of AI to improve efficiency data centers, in particular the cooling and the way the machine are running, virtualization. But it will be a good initiative, but it's not enough to reduce the load growth. So certainly, and of course, there is always also the other big coin that AI will improve efficiency in other sectors, in transportation and buildings, with automation and other things. So it has a good side and a dark side, if you want. And I was focusing mainly on the dark side, but everything, could also be taken into account. And the fact that I already mentioned, because not very much mentioned the fact of this small edge data center that can be even in the future might be our mobile phone. We don't know. We know that the mobile phone are also gearing up to have a much more processing power to run models. And so I don't know if only run or even develop models. So yes, this is also something to be brought to the attention of policymakers. But policymakers are always, if you want, by definition, looking 2 years in the past, when you are most probably looking 2 years in the future. So this is also this difficult.
Thanks a lot. You obviously have a very broad knowledge on EU energy and AI policies and use. So I think that's very interesting. But when you came to the conclusions, you do not connect really to the effects on other sectors from this predicted energy use. So I would like if you could say something about how this is connected, especially within the EU where we have already the ETS. So you mentioned here if we have gas-powered AI data centers that would increase fossil fuels, but that's not really true, is it? In the EU, you would instead reduce the amount of activity within other sectors. So which sectors would use less fossil energy if the data centers used more? This would be the case both within Fit for 55 and the upcoming, hopefully, Fit for 90.
Yes, I would have been another presentation, this topic, so we didn't have the time, and there's a lot of uncertainty. So even the grid can be managed in a much better way, the electricity grid, with AI, as well as, I say, traffic, which is a very large greenhouse gas emissions in the EU, and the industrial sector, which is declining, and buildings, which are still important. But again, there is a lot of assumption to be made, and a lot of so there are always ranges. So, but there are studies, and the IEA study that I mentioned, look at one side the consumption, the other side the benefit of IEA. So I can point you to that study to have some ideas, and nobody, neither myself, would like to stop the IEA, because there are a lot of non-energy benefit and energy benefit and greenhouse gases. But as I said, let's try to do it in a more sustainable manner, even without accounting the benefit in other sector. But if we have to grow the air consumption, it can be, optimized in the system, in the ICT sector, before helping other sector to optimize their consumption. Because in any case, we have to be climate neutral by 2050. So every single kilowatt hour that we can save, or move from gas to renewables, is important. And so we have to capture all of this in our economy.
Great. My name is Daniel Sheen from the University of Bristol. Thank you very much for the presentation. Many really difficult topics that you touched on here, trying to understand efficient use of AI. I have the feeling there are some less difficult problems that should be tackled first. And one of them, you brought up the point that, especially in Ireland, data centers constitute an enormous amount of the total electricity output. And it seems you don't have to talk about the efficiency of this. This is a question of the absolute use of energy consumption, of the total volume, and one that can be decided locally, it seems. Yeah, the planning the organization of the construction of data centers, those processes, they will already have visibility of the energy consumption. They will already have knowledge of what portion of the electricity consumption will go into data centers. And it seems strange that that we arrive at this state now when there is a planning process in place. Have you looked into this? Like what's going on there? Why are we suddenly waking up? Oh my God, 20% of our electricity goes into data centers. How did that happen?
Yeah, because when the big companies, and ironically, these large companies are also the most efficient one, because they have a lot of knowledge, a lot of expertise. Google, Amazon, OVH in France have really very POE below 1.2 if you use the old metric, but still they consume a lot. So if a country give a tax incentive to this company, try to attract them, they know there is skilled workforce available. There's people speaking English, like in Ireland. There are all favorable conditions, and so this company want to have to add data center. They look to this location because they know they have a favorable condition. 5 years ago, they were planning to build, and nobody say, attention, we don't have energy for you anymore. So only now, after they gave planning permission, most probably 5 years ago, when this company bought land 10 years ago, there is some attention to this topic. I know that Google buy, I don't know how, there's nobody from Google in the audience. They buy a lot of lands in advance where they think they might construct a data center. And in one case, in Luxembourg, there's been an ongoing discussion for 5 years with the Ministry of Environment, putting a lot of, saying you have to use only renewables, you have to demonstrate that you don't harm our electricity network, that you you use the heat, this and this and that. And what the result is this data center is not yet built. I don't know what is the discussion between the Ministry of Environment and the company. But this is what should happen. A local authority should put much more attention before granting a building permit for a new data center. There is enough power capacity. Will this cause inconvenience to the citizens or not?
Yeah, thanks for your talk. And also,
But maybe another small comment. I was last year in a conference. It was in Italy. Milan is following the step of Dublin, for example, and there were 5 mayors from municipality around Milan, and all of them welcome data centers. They say they're converting logistics, for example, centers to data centers, because data center invest and buy this infrastructure, this piece of land with the old infrastructure and put in data center. And the mayor was saying, we love to data center because they don't pollute locally. They avoid, for example, in this case, the lorry traffic, the truck traffic in and out of the warehouses. And so there was basically 5 mayors saying, we welcome as many data centers as possible in our local community. But maybe they look on the business side. They don't consult the citizens and don't see the implications.
okay, so thanks for your talk, and thanks also for the regulation you are putting in place. But somehow, don't you think it's time for a second stage of regulation? Because you explained you have a problem of the carbon emission. We have a problem of total quantity of energy which is available, and this energy, it's clear that if the electricity is going to data center, is not going to decarbonize existing sectors such as housing, transportation, basic industry that we all need, food and so on. And we are slowing down the decarbonation of those sectors, that is really the basic one, to implement data center for, I'm sorry, but you mentioned we should not slow down innovation, but I see buzzwords like smart cities, autonomous cars. If you ask population, they don't need that. I mean, people are not asking for that on average. So don't you think that European Commission should take a second stage and then put hard constraints on where the electricity is going to decarbonize really what is very important, the population?
This is a very difficult question because, first of all, as you know, in Europe, in the EU system, the Commission propose, and then the Council and Parliament decide. So member state and elected the representative of citizens. So I think there must be more pressure from NGOs, from the academic community, the scientific community on policymakers, both on MEPs, on the Commission. Yes, I'm listening to you. I tend to agree with you, but it's not easy to regulate in an area which is seen by a lot of member states as a very welcome development for their economy, so yeah, it's complex, and we should arrive there, but there are a lot of interest at stake and different views that are conflicting. But I hope this data and the data that you may have locally may at least bring forward to the policymaker to make the right decisions. And for example, I give you another things that I see personally strange, that the Gulf countries want to become a big data center hub because they cannot sell any more gas and oil to us. We are declining our consumption, so they have an abundance of them. So why not put in data center there? And again, there are agreements with some national governments to collaborate on this, to develop this. And it's not the best location. It's very hot, very arid. So they use power to create water desalination, then more power to power the data centers. And in the end, the initial slides on greenhouse gas emissions showing that is a global problem, and Europe right now is a small part. the large emission coming from other regions like China, India, most probably very soon, the Middle East and other places. But these are, again, my personal consideration. Don't take as Commission views.
Okay, the last one, don't worry. Thank you. Yeah, okay, you're the last one. Okay, we don't have time to speak about the AE, HPC and metrics, but I have the curiosity. Your slide presented the directive of May 2024. Then I ask to you if after 1 year, the member state sent the real data of the consumption of the data center.
Yes and no, because the obligation is on the data center operators to send the data. So majority of them us send the data. Was a kind of transition year. Now after 15 May of this year, there should be the second wave of data center data into the European database.
Okay.
Some member states organize they collect nationally, but I think this option was only followed by Netherlands and Germany. Other member states ask the operator to send directly the data to Brussels. So we have to see.
Yeah, just the status of the directive. Thank you.
One more question at the back, by the way. Oh, yes, then you. Yeah, is that okay?
No,
One there, somebody, okay.
It connects to what has just been said about the positive impact or negative impact in other sectors. I personally don't have a benefit if the financial centers in Europe can do faster trading. So the European Commission, in my opinion, should also make sure that the capacity, the computing capacity that is being built really is to the benefit or helps the people in Europe. And I think decarbonization could be one such area that is being supported. And I think data centers could also report on their positive impacts. And maybe there's a lever in industrial policy to make sure that not only the centers of Europe will be able to build these data centers, but also the peripheries, because otherwise then many countries in Europe won't benefit from the potential benefits. And I think last point, that if there's only big US companies that do their operations in these data centers, the benefits for Europe will also be limited, plus the sovereignty argument. So I think there are a lot of aspects that also need to be taken into account.
Yeah, this is very much in the attention of the policymaker. They don't want to leave these AI growth only to the benefit of US companies. Don't want to see basically all the data center built in the US. They want to have also data center in Europe. I think strategically they would like to have some European champion, but will they emerge or not? I don't know. I think we have a lot of skills in Europe. Our university is still leading university, but then the innovation is happening somewhere else. And I think the Draghi report has a lot of a point on this. So it's the picture is very big, and the choices that have to be made by our policymaker are very important and should be rapid. And I think what you say is I agree 100% that we should have a data center in Europe. We should have them in many different locations and as sustainable as possible.
Yeah. Okay, thanks, Paolo and Damien Dalton, the chair of the ICTVS conference this year. I think from the response, they showed a lot of interest. It was an excellent presentation. You could be here for a lot longer, but I won't delay much longer. Just one final question. The data centers in Europe now are regulated under the Energy Efficiency Directive, which came into force last year. And originally that was supposed to be for data centers that had an energy consumption of 250 kilowatts. But that threshold was pushed back to 500 kilowatts. Is there a sort of compliance with data centers with this directive, or is there sort of reluctance? And is it the intention that ultimately all data centers, no matter how large or small, will have to comply with like the EU Code of Conduct?
The moment the compliance is only to supply data, as I say, maybe a rating scheme will emerge, but the limit at the moment is 500 kilowatt of IT capacity. and I guess it will remain like this. And I know there are a lot of smaller data centers in Europe which are not that efficient because they tend to be a legacy, not professionally run, etc. So it's important to have action. The code of conduct, in fact, captures all of them, and there's a lot of interest in smaller data centers.
Thank you. Thank you very much for wonderful talk and really informative and some great questions there, and hope out of those questions we might get some more policy measures too to drive this problem.
Don't forget the data.
Yeah. Thank you very much. Really